Beautiful. And then I'm going to use my slope, a positive 1 for a rise and a positive 1 for the run. Positive 1 for the rise, positive 1 for the run. Or I could come back to my original point, negative 1 for the rise, negative 1 for the run. Now this one also I can see is going this way, and it is solid. So let's get that one graphed. A solid line right through here, and I'm going all the way from one end of my graph paper to the other, and arrows on each end every time we graph a line, because they do go on in both directions forever. Now I have my 2 lines graphed. Now I need to figure out where am I going to shade. And I know that for each line, like for example for this y is less than or equal to line, I'm either going to shade all the way over here or all the way over here. So let's figure out which way. With this line I can use 0, 0 as my test point. So I'll write it underneath that x equals 2 line, or less than or equal to. My x part is 0, so I'll say 0 is less than or equal to. And that is a true statement, so I know that I am going to shade this way. So at each end of the line I'm going to put an arrow, just showing that's the way I should shade for this line. So I know I'm going to shade this way for my x is less than or equal to. Now I'll do the same thing with my other equation. My y is greater than or equal x plus 1, and the test point can also be 0. I have to look closely, but 0 is definitely on one side of the line. So I'll do a test point of 0, 0, and that means I put in a 0 for the y, and then over here a 0 for the x. So I'll have 0 is greater than or equal 0 plus 1. 0 is greater than or equal 1. Now that's not true. It's a false statement, so it means that this line cannot go in this direction. It has to go in this direction, going up. So I'm going to put an arrow on each end of the line, because that's just going to help me see where I need to graph. Now when I want to actually figure out where are the place where I need to shade, I look back, I needed intersection and my intersection means the part that fits both inequalities. So if I look at my shaded areas, or where I should shade, it's all in this area here. This part over here is left unshaded for both lines. But what I need to see is that this one and this one point right to each other. They're pointing to the same region there. That's going to be the part that's in common, so I can just shade that part. So it's kind of a secret way to figure out which way to shade. This one wasn't pointing at any others, it's just pointing off that way, and the same with this one. These two are pointing to the same region, so that's the part that's in common. Okay, the last thing that I want to look at is domain and range. So domain, I'm going across in the x direction. I have a whole bunch of things that are included all the way up to right there at x equals 2. So I go from negative infinity to 2, and remember, because this line is solid, the points are up to and including the line, so the 2 is actually included. Now for the range, I'm coming from negative infinity, and I can see in the y direction, and I can see that there are points over here, and if I go far enough to the left, I'll eventually hit points that are included all the way up, all the way up, all the way up to positive infinity. So the range in this case is all real numbers. Remember, you always put your smallest quantity on the left, largest quantity on the right. So we're always looking left to right and bottom to top. Alright, we have another one. Graph the union of this inequality and that inequality. And first thing I want to write down, this one tells me I have a solid line. And for this one, I need a dashed line. So looking at the first one, I want to put it into y equals mx plus b form, since I can see I have two variables. So I'll subtract x from both sides, and I have 2y is less than or equal negative x plus 4. And then divide both sides by 2. That means each term. And I have y is less than or equal negative 1/2 x plus 2. That tells me my slope is negative 1 over 2 or 1 over negative 2. And my y-intercept is 0, 2, coming from right there. And then I'll graph the 0, 2, 0 in the x direction, 2 in the y direction. And from here, I'm going to use my slope, negative 1 over 2, so negative 1 for the rise and a positive 2 for the run. And then back to the original point, a 1 for the rise and a negative 2 for the run. Now I have enough information to graph this one, and it is a solid line. Double check. And so I'll graph a solid line here, all the way from one end to the other. And then I would like to do a test point, and I see 0, 0 again is a good point to use. So in the original equation, I'll put in 0 for the x plus 2 times 0 for the y is less than or equal 4. And I end up with 0 plus 0, so 0 is less than or equal 4. And that's a true statement. So I'm going to put 2 arrows. I need to include this point 0, 0, so I put a little arrow here and a little arrow there. So for this line, I should shade in the downward direction. Now my last one, my last inequality, y is greater than negative 1. I'll graph this one again with an xy table, negative 1 for my y's, and 0, 2, 4, whatever I choose for the x's. So 0, negative 1, 2 in the x direction, negative 1, 4, negative 1. And this one needs to be a dashed line, so I have a horizontal line. So I have a horizontal line at y equals negative 1. There, I made my dashes. And now this one, I can also use 0, 0 as my test point. So 0 is greater than or equal negative 1. That's true. So I am going to include the 0. So I'll put a little arrow this direction, arrow this direction. Now come back, I had the union and the or. Remember, that's like when we get married, all our furniture comes into the union, so we have everything that works for one and everything that works for the other. So I can see this quadrant is, or this portion is used because of this arrow here, and this one's going down, so this part here is included right up into there, and then this one is included also. So everything that has an arrow on it should get shading on a union. Now the part that's not shaded is this part right here. There. Now for the domain, remember domain is in the values for x, so I'm looking at values for x. There will be values all the way, all the way, all the way, all the way across. Even though this isn't shaded, there's still values up here and down here with an x part. So it'll be negative infinity to positive infinity. And then the range, remember, is the y parts. So come from negative infinity, values all the way up through positive infinity. One for you to try. Pause the video. Alright, I have two inequalities. The first one I can see should be a dashed line, and the second one should be solid. And if I solve this one for y, then I'll subtract 2x from both sides and have 4y is less than negative 2x plus